Hello again. Today I want to tell you about the claimed component compiler, how you compile Jupyter Notebooks into Kubeflow Pipeline Components, into command line executables, and into Kubernetes Jobs. Because I am always advertising this, but actually I told nobody how to actually do it. The reason why I told nobody how to do it is because I just wanted to create the PyPy package that you actually can do pip install C3. C3 stands for Claimed Component Compiler. But I'm not yet done, but I still want to share it with you because a lot of people just asked me how actually am I doing this magic. So I tell you the magic. So what you need to do is you clone this repository for now. It's claimed framework /C3. And then you will end up with here this create KFP component notebooks. So I'm a super huge fan of notebooks. I'm doing a lot of coding in notebooks and not in Python scripts. So actually this whole thing could, in theory, run in a Python script, but with an exception. In Jupyter Notebooks, you can mix and match Python code and shell code, and I'm heavily making use of that, even ingesting Python parameters or Python variables into shell code. You will see that in a second. So let me walk you through this notebook. You don't have to understand it, but just for the curious people, here I have just a way of generically read command line parameters you are passing to the notebook, because I don't want to actually hard code it. So I'm just using this exact parameter, which is in Java terms it's called reflection, but I'm just executing this. It's a key value string, and then you actually get this parameter as a variable on the Python heap. So for example, you will see that later. Notebook path is one of those parameters. And what actually we are doing here is we are passing the notebook. So don't go the details of the notebook parser, but we are extracting information from the notebook. And so for example, we extract the pip installs, so we know which dependencies the notebook is depending on. And then what we do is we create, first of all, a container image. So we have here a template. This root image we obviously can also parameterize. And then we have the requirements. For example, we can add additional files to the container image. We have our notebook, which we are introducing or integrating into the container image. That's our main code, which we are containerizing. And and then we just run it via IPython. So the notebook you are actually creating a container from is running in the container via IPython. That's the trick, And then actually what we do is we create the Docker image and we push it also to the to registry. You can now configure the registry. That's a new addition. Because you don't want to push to my registry always. That was hard-coded. And then the other thing is we want to extract the interface. Now, you might remember we have this cell in the notebooks which defines the interface to the component. So all the environment variables which the notebook actually reads to know what it should do, all the parameters, they are extracted. And now we are creating here a KFP, a Kubeflow Pipeline Component YAML, and that's actually happening here. And then a thing which is new, we are now also creating a Kubernetes job. And since I have all the information, it's super easy now to create different target environments. That's actually how it works. But now the way how you actually use it, it's super simple. So the only thing, let's actually do this here with one component we have in the public claimed component library, which is util cost. So it's a utility to read and write and sync data from and sync data to cost and delete data and search for data in Cloud Object Store, no cost, Cloud Object Store /S3. And the way how to create such a component from the original Jupyter Notebook is just here very easy. You say IPython to run the actually generate KFP component notebook. Obviously, you set a version here. And then you have 3 parameters at the moment which are required. One is the notebook path. Obviously, you want to tell the compiler the source notebook it reads to create a component from. And then you have here the version. And then you have the repository, where the component container should be pushed to. And you just run it, and after that, what you get is actually, let's go to the actual notebook and the created YAML file. So this is the cosutil notebook, no? And what you maybe remember is you have to set the name and the description here, the dependencies, and also the interface, no? All the parameters you need to actually define like this, no? You have to have a comment, you have to have OS environment get, and you can also have default values, and also you can cast the boolean, float, integer, something else. So string, it's anyway integer, float, bool. Yeah, I think those 4 types I'm currently supporting. And yeah, and the rest is basically your code. And out of that, I'm creating here, in this case, a KFP component YAML. Sorry, no, I'm creating more. I'm creating a KFP component YAML. So this is the YAML. And since today, I'm also creating a Kubernetes job YAML. And you just have to fill in the parameters here, and you can then actually send it to Kubernetes as a Kubernetes job. And obviously, you have the command line. You can run it on a Linux shell via the claimed CLI anyway. Okay, I hope this is making stuff a little more clear, and I have just uploaded in my previous video some more explanation on how you use this Kubernetes job and also how you can scale it. I have implemented a generic grid computing pattern, and you can just shard by files, and you can just linearly scale up the stuff, and it's super fast. It's super cool. Yeah, take care, have fun, and talk to you soon.